Hey everyone, and welcome back to OnCoffee. I'm your host Vahe, and today I'm with Dr. Ugur Uslu from the University Hospital Würzburg. He's just taken on an associate professor role. He's setting up a new lab, and he's worked in one of the most famous CAR-T research groups in the world. Ugur, great to have you. Welcome to OnCoffee.
Thank you so much for having me. I'm totally excited to be here today.
Yeah. Okay, let's go. Before we start our conversation, I want to share a coffee story. Let me ask you a question. Do you know the purpose of the first office web camera?
No, I do not.
Okay. So the very first office web camera was set up just to check if the coffee pot was empty. That sounds crazy, but it is what it is. It is known as the Trojan room coffee pot camera and was invented in 1991 by researchers Quentin Stafford Fraser and Paul Jardetsky at the University of Cambridge in the computer laboratory. So the camera was connected to their internal lab network. Mainly, the laboratory was shared between the scientists, and it has multiple floors, and scientists were located in different floors, and it was difficult to move from one floor to another. Not difficult, but time consuming. So the camera was set up for a purely practical reason, to save the researchers from the disappointment of walking to the coffee pot in the Trojan room only to find it was empty.
So
Then in 1993, when web browser learned to display images, Daniel Gordon and Martin Johnson connected the camera to the internet. Overnight, a lab coffee pot became a quirky early web celebrity watched by people all over the world, right up until it was retired in 2001. As they say, modern problems require modern solutions. And we don't know how our inventions will work in the future. So on that note, what is in your cup today? And do you have a little coffee ritual that keeps your day moving?
So actually, I have one cup of normal cafe crema, it's called. So it is like some kind of Americano, I would say. Like it is a mild coffee. It is not that strong. I love drinking coffee. So I need in the morning my 2 cups. I need in the afternoon another 2 cups. And then I'm fine. So that's also a funny story, actually. So when I was younger, I started drinking coffee when I was like 22, 23. It was like towards the end of my med school where I had to study a lot. Before that, I was never drinking coffee, actually. But then I started drinking it, and at the beginning, I could actually see an effect. I could see that I'm more awake and that it activates me, and then the number of cups increased over the next few years. And now I'm just drinking 4 or 5 cups of coffee because I like the taste, but it does not actually have an effect anymore. I can drink a coffee before I go to bed and I can sleep. So it's basically, yeah.
Yeah, it's a well-known effect. Your adenosine receptors need to again grow back to work. So that won't work. You can quit for some time, then start again. It will be difficult.
No. Now, if I don't drink it, I get headaches. So now it's like I needed it. But that's not the reason I'm drinking it. I really like the taste, like it's like a ritual.
Yeah, the taste and also the culture when you can sit down with your colleagues and or your family members or your friends, have the coffee and chat. So that's a good thing.
Yeah. It's cool.
Okay, so cheers.
Cheers to you. Thanks again for having me.
Okay, could you please give us a short version of your journey? How did you decide that you want to specialize in immunotherapy, especially in CAR-T therapy, and how things went for you?
Yeah, so I was born like in the southwest of Germany in Stuttgart. So I don't know if you know that it's actually a big city. We have a good soccer team now. Actually, I went to med school in Tübingen, which is also in the southwest of Germany, and then I had my residency in dermatology in Erlangen, which is also it's in Bavaria. It's southeast. But when I started my residency in Erlangen, the head of department back then, it was Gerold Schuler. And we had our own GMP laboratory. So GMP is good manufacturing practice. So we were producing dendritic cell cancer vaccines in our own laboratory, and it was a very high quality. You could apply to patients. It's not like a research level. It's really like a higher production level. And we produced the dendritic cell cancer vaccines, applied it to our patients, the melanoma patients back then. And that got me really into translational research to really develop your own therapies and then apply it into your own patients to see both sides. And I'm lucky and fortunate that I could see that actually, and that I could get involved. In Erlangen, I also worked preclinically. That was not in clinical trials yet. So it was preclinically on CAR T cells, melanoma. And that's like why I decided, because CAR T cell or cancer immunotherapy in general is the field where I want to go to, the translational field. And that's why I decided to do a postdoc in the US. So after finishing my residency in dermatology, I was 5 years until recently, actually, in the laboratory of Carl June at Penn. Yeah, and there I did the same. We worked preclinically on CAR T cell constructs and solid tumors, tested them in vitro and in mice, and then like the pipeline to transfer it then into early phase clinical trials. That's also something which Carl really has established so well at Penn. So now I'm back in Würzburg and trying to do the same, basically. But I've been here 3 months only, so I'm getting started still. But yeah, it's exciting. It's exciting.
Yeah, immunotherapy is really moving. Is moving really fast. So it's a great field. And one of my previous guests, her name is Lucine. She was also doing research in CAR T, but for brain tumors. She was also involved in that. She have done PhD in the field. So yeah, it's really great thing. Actually, you partially answered my next question about the United States things, but I want a more comprehensive answer. So, could you please take me back to the States? How did you end up in Carl June's lab, and what did you walk into on day one?
So, it was always my aim when I was a resident physician. I was into cancer immunotherapy. I also did CAR T cell research in vitro, like preclinically. And I had my list of like 3 names where I wanted to do a postdoc. And Carl June was a number 1 because like he's the one, who is a pioneer in the field. And the first CAR T cell product which got approved for leukemia and also lymphoma is Kymriah. It's a product of Carl June. Novartis licensed it, which was totally cool. And back then, so I was planning to go into Carl June's lab as a postdoc, but of course, like everyone is flying into his lab, I think. It's like, it's Carl June, And what I did is I was always looking like, where will Carl June go to meetings? In Europe, in Germany, cancer immunotherapy meetings. And then I always was looking for him after his lectures and talking to him. I took pictures of him, sent it to him on the email. I don't know if that helped, but I was always telling Dr. June, like, one day I want to be a postdoc in your lab. And I always kept those pictures, And then when it was time for me to really move forward, I finished my residency. There was time point for the postdoc, right? Because I finished the 1 step. I'm now a trained dermatologist. Now I need my postdoc, my fellowship. That's when my boss back then, Gerold Schuler, he emailed him. And Carl also knew me from like the meetings and the pictures together. And that's how it worked out. But at the beginning, I also had a grant. So I applied for a grant in Germany, the Deutsche Krebshilfe, the German Cancer Foundation, if they could support me. And the grant got approved. Carl decided, like, offered me a position, so I could start back then. And it was actually in 2020. So I was supposed to start in April 1st, 2020. And just like 2 or 3 weeks before I wanted to fly to the States, COVID hit. And I will never forget that Angela Merkel, she was our chancellor back then. She talked to the people, like she was on television telling everyone that the next day there will be a complete knockdown and the flights, the borders were closed. I mean, Donald Trump was back then in his first term of presidency. He closed the borders to the US and then I couldn't go to the States. It was like really horrible. I was stuck in Germany because I did my residency in Erlangen, which is like 2.5 hours away from where I'm from, where my family is. So I already had to give up my apartment. I sold my car. I moved back to my parents basically just for the 1 month before I go back to go to the States, So I was stuck. I was like in my parents in my old room where I was as a child, And I was checking the news every day, like for the updates on COVID, and the numbers increased. There was no vaccine back then yet. And it was not possible to fly to the States, to start the postdoc. But it was all good. Like with my PI back then, with Carl June and stuff, like they all understood because everyone was affected. It was not just Germany, right? It was like the whole world was affected by the pandemic. I had to request for like a exception, kind of national interest exception at the government, the US government. It took like months, and then I could start my postdoc in the end, like 3 or 4 months later. I think it was mid-August when I could fly to the US finally and start my postdoc. So the beginning was like, it was struggling a little bit. I thought, oh my God, if the start is like this, like how will this continue? Because still I was in the States, but still, the laboratory capacities was still not on full. It was, everything was starting to open up slowly. But then of course the vaccines came, thank God, and the borders opened. So everything went fine in the end, At the start was like really, it was exciting.
Yeah, it was a really interesting story. You got the grant, you got the position, and then COVID, boom. So yeah, but hopefully everything end up well for you. So
Yeah. No, I also got my visa stamp already. So I was already at the US embassy back in January, It was January. I was at the embassy. I had my stamp to travel to the States. It was really, even with a visa, you couldn't travel at all because the borders were closed.
Yeah.
It was like really difficult times, but yeah, everything ended up great.
Yeah. And I guess you learned a lot in the States. What changed in the way you think about the science while you were there?
So my time in the US was really, really amazing. It was, of course, it is like new people, new culture, a new country. It is really nice to be in a infrastructure. Like that was the primary goal for myself, to really go to Carl June's lab, because it is a laboratory which is focused on CAR T cells, of course. He has established a platform where you test your CAR constructs in vitro, preclinically, and then move into clinical trials, and everything is like within one building pretty much, and it was for me personally to see like a huge lab. I was back in Erlangen in a small lab, right? We were like just a few people, and now I was in a building full of scientists, a huge lab, and also like the working, like the less bureaucracy also, which was totally nice in the States.
Like less nicer?
Yeah, I mean, in Germany, there's like a lot of bureaucracy.
In Germany, it's really bad.
Yeah. And in the US, everything is also digital. That is amazing, know? In Germany, it is only the sending is digital. So basically, they send you the form as an email. You need to print it, sign it, upload, like scan it, and then send it. Like the sending is electronic, but only the sending. So yeah, that was really cool to see that everything is digital, and also the discussions, like our lab meetings, like it was like the seminars and lab meetings. There were people who knew, of course, a lot on T-cell biology or T-cell engineering, and it was really amazing to have scientific discussions, to talk about your project, because if you talk with people who are like really good in that field and who are also willing to help you, of course, and give input, that makes you also move forward nicer in your project.
Yeah.
So that was really amazing. Yeah.
But I know that in every project, in every fellowship, in every study, there is not only good sides, there are also bad sides or difficult parts. So could you please tell me something that was harder than you expected in the project, or to move into United States? Because like Germany, United States are culturally really different.
Yeah. Yeah, so I have to think about it. I'm not sure what was actually challenging. I mean, um, to be honest, like I really had an amazing time. Like I was lucky that my projects also worked out. I mean, there was times when my experiments didn't work or something, but that's also an advantage when you are in a huge lab with like 50, 60 people. There is someone who you can ask for help,
Yeah.
like someone will know you and can help you. So that's how we fixed it. So it was a very collaborative atmosphere. So I never had the feeling that basically something is not going well, whatever. But it does not mean that the US is better than Germany. I mean, my time in Germany before that, I was also in the lab in Erlangen, right? That time was also amazing. I don't know, maybe I'm lucky and everything is amazing.
Yeah, yeah.
Could be.
So let's say the worst thing was the COVID.
Yeah. I mean, yeah, that was thing because the COVID was that was not something which what I could work on and improve. You know what I
Yeah.
mean? So normally, if your experiment doesn't work, you think about it, you do troubleshooting, you repeat it and try to change things. Maybe you put in effort by yourself to improve it, or you know what I mean. But like COVID, there was like a higher power. So
Yeah,
no matter what I do, like I cannot control. I can just not travel to the US. It's
yeah. I just remembered the song from Mika, a French singer, if I'm not mistaken. Like, relax, take it easy. There is nothing we can do. So
yeah,
yeah, that was the situation. We can't really do anything. Just to wait and wait for the vaccines or just a
yeah,
treatment. So yeah,
yeah.
I can imagine the frustration you had.
Yeah, no, but that was actually the time when I really appreciated like life, I would say. It was like it was the first time when you had these restrictions, you couldn't go out and stuff, and then the freedom which you have normally. So I really appreciated that back then. That like once COVID is over, I will have a completely different life because I will now appreciate that we are healthy and there's no pandemic or something going on.
Yeah,
Yeah, yeah,
yeah, yeah. So, Ugi, you went to US, you did your research, you did your project, then you came back to
yeah,
Germany, obviously, and you just launched your lab.
yeah.
What are you actually doing in these early months?
My focus of my research is CAR T cells in solid tumors with focus on melanoma and cutaneous malignancies. So during my time in Carl Jean's lab, I worked on different projects which you could all publish. So I worked on combination strategies. I combined CAR T cells with different treatments. So in my first project in Carl June's lab, we combined CAR T cells with surgery. We applied CAR T cells intraoperatively because there are tumor entities like the colleague you said she's working on glioblastoma. Glioblastoma is one solid tumor. You cannot surgically resect everything. You will always have residual tumor cells. So our idea was to cut out as much as possible and then to apply CAR T cells intraoperatively on the wound and then close the wound.
Mhm.
And we mixed the CAR T cells in a fibrin glue-based carrier. Fibrin glue is approved to stop bleeding. Surgeries, you can use it in human. And our aim was to mix the CAR T cells in a fibrin glue-based carrier to make the CAR T cells persist or stay longer on the surgical site because it's a big surgical excision. And we apply the CAR T cells on the wound, on the lesion. And with the fibrin glue, we were hoping that the CAR T cells will stay longer on the wound. Otherwise, they will just be gone, right? If you put like a liquidy solution there. And it worked. So we showed it in 4 mouse models that this approach works. We showed it in the feasibility of the study in 2 xenograft animal models, triple negative breast cancer model and henopancreatic cancer model. We showed that there is less toxicity of the intraoperatively applied CAR T cells when you compare to IV injected CAR T cells. We showed it in a transgenic toxicity mouse model. And in syngeneic mice, we showed that the intraoperatively applied CAR T cells do not cause wound healing because since you apply the CAR T cells on the wound and you close it, there might be inflammation that might interfere with wound healing, right? So we didn't see that. We could publish those data. And in parallel, that's what I mean with the pipeline, what Carlton has established. So while I was working on the revision of my paper, like another team, they were already writing the clinical trial protocol, and my paper got published, and the clinical trial is basically is about to start. Like everything was pretty much in parallel, and that's very nice to see that the work you're doing in the lab is actually moving into the clinical trial to patients. So there was one project. My other two projects was combining CAR T cells with a new STING agonist, because by first injecting the STING agonist intratumorally, you can change the tumor microenvironment, and then you infuse the CAR T cells. And we were hoping by combining it with a STING agonist that the CAR T cells will traffic better into the tumors, which worked very nicely. That we published in Nature Communication with me as a first author. And my third project was, which was published in PNAS, where I'm a shared first, is combining CAR T cells with the photon radiation. So photon radiation is a new form of radio treatment where it has the same anti-tumor efficacy like the standard radiation, the photon, but it preserves healthy tissue.
Yeah.
And that we showed in orthotopic mouse models that actually works, that it's synergistic. So in the 5 years where I was in Carl Jude's lab, I could publish 3 papers as a first author, which was pretty good. Like I was lucky. It was not like 3 Science and Nature papers. It was Nature Communication and PNAS and Science Advances. So it was, double, so it's fine. But with that work, I'm now basically continuing my work in CAR T cells and solid tumors with focus on melanoma. So I established my lab 3 months ago. I have 4 CAR constructs, which I'm using, which are specific for melanoma and Merkel cell carcinoma. And we're going to combine CAR T cells with different treatment, checkpoint blockade, oncolytic viruses, because like melanoma is an immunogenic tumor. There are approved T cell or immunotherapies or other treatments which are very attractive to combine CAR T cells with. For example, checkpoint blockade is approved, which you can combine. Oncolytic virus is approved in melanoma, which you can combine. Or TIL therapy is improved in the US now. There are like very attractive treatments. And I think if you want to run a clinical trial on melanoma, for example, and you want to test a combination treatment, it's probably easier if one of the 2 treatments is approved. And, if both are experimental, it's probably more difficult. So that's what I'm doing now. So with my position here, I'm an associate professor now. I'm also in the clinic. I'm an attending physician also. With my position, I got a postdoc, 2 technicians, and a student. So I hired people the first 3 months since I'm here. That was also not that easy, to be honest. Like you announce the positions, people apply, you have interviews. It really is time consuming, but I hired my people. I submitted 5 grants. I started collaborations, here. In Würzburg, like the reason why I really wanted to come here to this institution is because there are people who are already working on CAR T cells, and there are already early phase CAR T cell trials. So I don't know if you know Michael Hudecek. He's well known in the field of CAR T cells. He's the director of the CAR T cell program here in Würzburg. And of course, I'm working very close with him. He has his clinical trials already running, so I can maybe use this CAR construct and also include melanoma patients. And in general, like here is basically the institution where I really wanted to come back to, and I'm happy that it worked out. It was also a coincidence, to be honest, because my plan was always to come back. I could have also stayed in the States without problems, right? But my plan was always to come back. And then the position which I got now opened up by coincidence, because the professor who had this position before me, he's now the head of department of dermatology in Frankfurt. So he went there and this position opened up. It was announced like 2 years ago already. And then I applied and it worked out. So I'm totally happy that it worked out.
Yeah, that's really great. So you're doing a really good job. Like you didn't stay in US, you decided to come back to Germany. I think it's the best decision because you are disseminating the scientific knowledge. Like if that knowledge stayed in the US, so it wouldn't be better. So science is only moving forward if we share our knowledge between our colleagues, our friends. So other people also doing that, and we are by that we can move really fast. Yeah. That's the whole logic. There is no rocket science here.
Yeah. And I'm still collaborating with Carl. I mean, he's my mentor. I'm so grateful to have him as my mentor still. we're like, we always email, we talk, like, because I'm here, it doesn't mean that I'm not working with my mentor anymore or with the US. You know what I mean? So it's like you said, I'm here now, and now I'm spreading my knowledge in
Yeah.
Germany and still collaborating, because science is about collaboration. That's very important.
Yeah.
Because I saw how it works in the US. So Carl Drew's department, it's really amazing. Like, it is so collaborative. People are really helping each other. And the platform which he established, of course, he didn't do it like within days. It's work of like 20, 30 years, to do that level of research. But that's also where we need to get to in Germany, for example. We need to, it's not only me. I need to work together with other people here in the institution. We need to collaborate and work together and try to be competitive as an institution and also as a country and Europe as a whole. Like, it's like a whole community, in my
Yeah.
opinion.
Yeah. Yeah.
So yeah, I'm also happy to collaborate with Armenia. So,
Yeah, yeah, yeah. That's great. Actually, we are trying to do a trial. I'm not sure if it's okay if I tell it right now, but I will tell you later.
you can tell, it's fine.
Yeah, I will tell you after our recording. So yeah, okay. I will remember to tell it.
Yeah. No worries there.
Yeah, yeah. Okay, in skin cancers specifically, what questions do you want your next research or, I don't know, trial to answer?
I'm really trying to develop new CAR constructs. So we need to find new antigens, melanoma antigens, to target melanoma, for example, And if you have new antigens which are uniquely expressed, so the best thing would be to have antigens which are just expressed on the tumor cells, because then you don't have toxicity. The CAR T cell, it's a T cell which is engineered with the CAR, and the CAR recognizes an antigen. But if this antigen is also expressed in healthy tissue, in the liver or somewhere else, you might also damage the healthy tissue, which you don't really want. So it would be amazing if I could find new target antigens, develop new CAR constructs, specific for melanoma, uniquely expressed, specific for antigens uniquely expressed on melanoma, and then move into clinical trials. Like, that's my overall goal.
Yeah, that's great. I hope everything will settle up perfectly for you.
No, I hope so too. I mean, I'm trying. We're all trying, and
Yeah, yeah. So I want to ask, if we check back in 2 or 3 years, what will feel different about solid tumors and CAR T?
So I think that we will have this is a recording, right? But I really think we will have our first approved CAR construct.
Oh,
in glioblastoma, probably.
that's
So
great.
because, when you look like CAR T cells and solid tumors, it's like a very advanced story, like it's approved in hematological malignancies, in leukemia, lymphoma, multiple myeloma. It's very successful there. There are clinical trials now. They're moving it to first line or second line. They want to move it to earlier line, So which is like really great. Now there is evidence that CAR T cells are also seem to be very greatly working for autoimmune diseases. I don't know if you heard that. In refractory lupus or systemic sclerosis, there are really patients who don't have lupus anymore. And before that, they were taking 50 pills a day. Like patient number 1 in Erlangen. She was a young patient. She had a lupus. All organs were involved and affected, and she had all kinds of treatment and it didn't help. And then they gave her 1 infusion of CAR T cells. And since 3 years, she doesn't have lupus anymore. I mean, I don't want to say she's healed because we need to wait for that, of course. But since 3 years, she doesn't have lupus anymore. She doesn't take any pills anymore, So that's like really nice to see. So it works very great in hematological malignancies. It's approved there also. In autoimmune disorders, it seems to work well. But CAR T cells and solid tumors, we are not there yet. We're not at a level for approval. But when you compare it with 10 years ago, like, we understand way more on CAR T cell biology or T cell biology in general. We understand way better what the reasons are why CAR T cells don't work that well in solid tumors. And we are focusing on these questions and trying to find strategies. And I think last year was the first year, 2024, it's already 2 years ago, where Crystal Maycall and Marcella Maus, they both published like New England Journal papers, Nature Medicine papers on glioblastoma trials, where we, for the first time, I would say, where we could really see an effect. And also other studies in China were published, like last 2 years, they were really the first time CAR T cell efficacy and anti-tumor effects, which we could see in clinical trials. So we're slowly moving there. And I think glioblastoma will hopefully be the tumor entity where we might see approval, but we need to wait for that, of course, and we need to work on it. Yeah.
That would be perfect, because right now for glioblastoma there is no effective treatment.
Yeah.
But
That's also the other reason. Like, of course, you're testing CAR T cells only in entities where you have no treatment options. Which are very difficult to treat, which is also good, because there is a need. You need to find a way to help those patients, because nothing works. If you tested maybe CAR T cells in other tumor entities, it might work better. I don't know, so glioblastoma is a very tough one, really, really tough one. But I think we will get there, hopefully.
Hopefully. Yeah.
So I can say it now, because I saw an interview from Carl June like a few months ago, and she also said that. So if Carl June says it, so I can also say it.
Yes, indeed. Then let's have another meeting after the first treatment of glioblastoma. Not treatment, but after
Approval.
first approved drug for glioblastoma.
Okay. So that's a deal, right? So the first CAR T approval in solid tumors, let's say solid tumors in general.
Yeah.
Let's not stick on glioblastoma. Let's say solid tumors, any solid tumor. Then we'll have another coffee meeting. Okay, it's cool.
Yeah. So, Ugi, you already talked about your mentor, Carl June. I want to ask a question. What is an advice or something that you still can hear in your head today from Carl June?
From Carl June, like, just to be collaborative, because science is collaboration. That's always what he said. By working together, by sharing your experiences and your knowledge, that's the only way we all move forward. In the end, our aim is to help the patient, like help humanity, like, let's put it that way. And we can only do that if you really work together. And that's why I really admire him. And that's also the atmosphere, which is in his laboratory and in his department, like that collaborative atmosphere. And I think that's really the spirit, and that's really important. So I'm trying to bring that spirit also over here. So I hope I will be as successful as Carl, but let's see.
Yeah.
But that's always what he was saying, collaboration.
That's a great advice. Yeah, well, the best thing in the world, I think, it's the collaboration and network between different peoples, because if you're alone, you are no one, I guess. That's my opinion.
Yeah. And it's also more fun. Like, I think it's so
course.
much more fun to collaborate. Look, it's like we're just talking. It's so much fun to talk with you, like.
Thank you.
Yeah.
Likewise.
So, I mean, we're not like talking like about projects or something, but like just in general, like when you share your experiences and stuff, it's nice,
Yeah. I know we are doing the research, you are doing the clinic. I guess you don't have any free time, but as they say in Germany, in Deutschland, as they say, Sonntag ist Ruhetag, and which basically translate as Sundays for free time. How do you spend your Sundays?
So that is really, like, I got back from the States after 5 years, and here everything closes at 8 p.m. Sunday is closed, everything. Oh my God. In the US, in Philadelphia, it was like, I think 2 million people are living there. It's a huge city and everything is open 24 hours. Like I never thought about that the supermarket might be closed or something. So, I missed that. But what was the question again? Actually, I was stuck with
how do you spend your Sundays?
Oh, my Sunday. So my Sunday, I spend it, with my girlfriend in Frankfurt. So she lives in Frankfurt. So I go there often, having my coffee in the morning, checking my emails, doing something fun. Maybe, going for bowling or something, like something chilled usually. And I work a lot, of course, but it is also important to have like a private life and stuff. Like it's not like 24 hours just work, but there should be also time to really relax and do things outside of work. I think that's super important.
That's pretty important, because if you don't have any free time to do the things we love besides the medicine, I think we would have gone crazy. We are not robots, and I think even robots can't do the same work over and over again without relaxing. So it's really important to take some time for ourselves and
Yeah.
just chill.
Yeah. No, but my Sundays are really slow usually. Like, just chill, like sleeping, drinking coffee, doing something fun, whatever,
Yeah, that's really nice. And my last question for today, as most of our listeners are young doctors, young researchers, students, what advice would you give to them?
I would give the advice, just do your job and deliver, So because a lot of people, when you have goals and stuff and you want to reach the goals, you need to work for it, of course. But if you're a student and if someone asks you, your lecturer or like whatever, like, or your supervisor asks you for something small, even that small thing, just try to do it as good as possible, just try to deliver, because also the small things are important, and the next time you'll get a more important task to do. And that way you gain trust and then you get supported. Just like, do what you like to do and just deliver, even if you think it's maybe totally not important at all. You know what I mean?
Yeah.
Like,
Yeah, I completely agree with you. I think there is no good or bad information. Like, if you think it's not important, maybe it's important for others. As Einstein said once, if your research results are negative, you should need to publish it or share it, because maybe someone also wants to do that. And if they see if it was negative, they wouldn't waste their time doing that. So it's important.
Yeah. No, definitely. Yeah. And be collaborative. Be always nice. I think it is so important to be just kind to people, because we are all the same in this world, So
Yeah.
why being rude?
Yeah,
Just
of
be
course.
nice to everyone.
Course.
Yeah.
Of course. So, Ugi, thank you so much for taking us from your CAR-T chapter in the US to launching your own lab in Germany, and for a clear, grounded look at where solid tumor CAR-T is heading. It was really interesting to have you as a guest and have a talk with you. I had a great pleasure talking with you.
Yeah. Thank you so much again for having me. It was also a pleasure for me to talk with you. And see you then, maybe in 6 months, if there's an approval for CAR-T.
Yeah.
So we never know. Maybe tomorrow.
Maybe tomorrow. So we'll be in touch. And to everyone listening, thanks for joining us on OnCoffee. If you enjoyed it, subscribe, share, and don't forget to keep the coffee brewing. See you next time. Bye-bye.